Hello, I am Hamid Arbai, and today we will talk about Azure API Management, how we can architect for performance and security. So this session will provide a comprehensive deep dive into Azure API Management. We will focus on optimizing API performance and security. It is designed for developers, architects, and IT professionals who want to leverage Azure's capabilities for efficient API management. The session will blend theoretical insights with practical demonstration, highlighting how to architect APIs for optimal performance and robust security in the Azure environment. So who I am Microsoft MVP in developer technologies. I am also Microsoft certified trainer, Docker captain, cloud solution architect. If you have any questions after this session, you can reach me on Twitter, LinkedIn, or by email. You can follow me on my Medium blog also. Today we will cover some concepts. So we have 4 sections. The first one is about API requirements and challenges, the different advantages of using an API management platform. Next, we present an overview of API management and the advanced features. After the section 3, we will present the build of robust, secure, and scalable APIs, and in the end, we will talk more about security best practices in Azure API management. In today's digital landscape, APIs play a crucial role in connecting applications and enabling seamless interactions. APIs play an essential role in modern web and mobile application architecture, data management, business integrations, IoT interactions, enterprise applications, and microservices architecture. So the use of APIs followed the same path to innovation as websites. API or the use of APIs have become an integral part of software development, allowing different applications and services to seamlessly communicate with each other. However, as companies increasingly rely on APIs to streamline their workflows and enhance their products, they are also encountering several challenges in API integration. To use APIs or participate in the API economy, you must address a number of requirements and challenges related to monitoring, managing, and securing APIs, including to engage in the API, including different challenges with the reuse, for example, like facilitating the support of legacy APIs without the need for extensive rewriting, enabling smooth transition and integration. Another challenge from the different challenges is the access without headaches. So, streamlining and automating the process of providing developers with easy and intermediate access to APIs, reducing administrative complexities. We have other challenges in security to ensure the robust security of backend system and implementing measures to protect APIs against unauthorized or excessive use, safeguarding sensitive data. For visibility, here if we talk about that, so we need to focus more on establishing mechanisms to measure and monitor API usage, which means that we need to understand which APIs are in operation, the extent of their utilization, and identifying the parties involved. Successfully addressing these aspects is vital for creating a seamless and secure environment that will encourage API adoption, fosters collaboration, and maximizes the benefits of participating in the API economy. So, let's talk more about API supports, how we can decouple through facets. Companies releasing APIs bear the responsibility of systematically advancing them. It's crucial to acknowledge that when developers use a published API to code programs. Any substantial changes to the API require writing their programs, avoiding the imposition of modification to applications with every API change. IT organizations frequently opt for simplified facets. These facets effectively decouple the internal implementation from the API consumer or experience, offering a streamlined API tailored for specific use, allowing its organization to modify the underlying implementation without affecting developers' application. Importantly, Facets enables transformation, enabling IT organizations to support legacy APIs such as XML and SOAP, for example, with never standard, with newer standard, we said, so without the need for recording and reworking the original API. The efficiency gained through reuse often justifies investing in an API management platform. So what is API management platform? Let's discover that. An API management platform is a robust software solution crafted to streamline the entire life cycle of an application programming interface. This is the abbreviation of API. This platform offers a suite of tools and functionalities tailored to support various phases of API development, deployment, monitoring, and maintenance. It encompasses features such as API design and documentation, security and access control, traffic management, analytics and reporting, versioning and lifecycle management, developer portals, and monetization capabilities. By leveraging an API APIs management platform, organizations can efficiently create, publish, manage, and secure APIs, thereby enhancing interoperability, scalability, and developer experience while maximizing the value of their digital assets. At its core, an API management platform acts as an intermediary between the API and its users, whether they are consumers, partners, or developers. Instead of interfacing directly with the underlying services, developers connect to the API management layer, which furnishes all necessary functionalities for safe, successful, and scalable API utilization. The API management layer serves to safeguard and fortify the communication channels between the API gateway and the backend systems, while also facilitating efficient API lifecycle management, and similar to how content management and e-commerce systems offer pre-built components for tasks like, for example, shopping carts, payment processing. API management systems provide standardized processes such as user onboarding and offboarding, reporting, and analytics, API key and authorization management, and throttling. All of these functionalities are configurable and can enforce request policies to safeguard APIs, ensuring that only authorized calls are permitted and that usage remains within defined conceptual limits. And Azure API Management is an API platform, management platform. So, the system is made up with the following components. Let's start with the first one, that is the API gateway. And it's the endpoint that will accept API calls, routes them to your backends. It can be one backend, more than one backends. It's ensure to route between the different backends. It verifies API keys, JWT tokens, certificates, and other any credential that you may use. Enforces usage quotas and rate limits. It transforms your API on the fly without code modifications. We have also caches backend response where set up and logs call metadata for analytics purpose. This is about the different functionalities or let's say components related to API gateway. And Azure API Management offers a self-hosted gateway. Why we need self-hosted? Which means that I will install the API gateway internally on site. We will not use what is already inside Azure API Management. So with the self-hosted gateway, consumer can deploy the API gateway to the same environments where they host their APIs. Why? To optimize API traffic and ensure compliance with local regulations and guidelines, for example. The self-hosted gateway enables customer with an hybrid IT infrastructure to manage API hosted on premises and across clouds from a single API management service in Azure. The self-hosted gateway is packaged as a Linux-based Docker container and it's one single container. This is why we call it's one Docker container and is commonly deployed to Kubernetes. Also, if you'd like to use, you use already an orchestrator internally based on Kubernetes. You can use, for example, it includes to Azure Kubernetes Service and Azure Arc enabled Kubernetes. It depends from what you are using as orchestrator internally in your company. Another component inside Azure API Management, that is the Azure Portal, is the administrative interface when you set up your API programs. It used to define or import API schema, package APIs into products, set up policies like quotas or transformation of on the APIs, for example, get insights from analytics, manage users. Another component dedicated developer, that is the developer portal. It serves as the main web presence for developers where they can read API documentation, try out an API via the interactive console, user interface, really, it's a friendly user interface, this portal, and create an account and subscribe to get API keys, access analytics on their own usage. So this is about Azure API Management and different components. Let's take a look more about API Management as a platform. So we can say that it comprises three key components in this case. We have the API gateway. We already presented that before. We already say that this component serves as one of more policy enforcement points within the data plane in this case. It acting as the entry point. It evaluates inbound API requests against a set of policies to define access authorization. Authorized requests are routed to the backend service implementation for transaction processing. As you can see here, we have control plane, data plane, API gateway it's inside the data plane, and we understand how it works. And the administrative portal and developer portal, they are the control plane. So administration portal functioning as the policies administration point within the control plane. This portal enables API providers to add APIs to the API catalog, configure API products, manage security, traffic, and monitoring policies. We have in the control plane also developer portal as a part. So this is self-service user interface, facilitates discovery and onboarding of APIs within the API catalog or marketplace, access to API documentation, testing, subscription, and analysis of API usage for API customer developers. The administration portal and developer portal are integrated inside the control plane. When an API gateway, here we talk about data plane, we can see that we have two types, self-hosted or hosted service in the cloud, we mean here in Azure. So when an API gateway data plane is deployed, it registers itself with the control plane and retrieves relevant policies. And during runtime, the API gateway operates independently of the control plane for enforcing API request policies. However, it does receive policies, updates, and reports API usage metrics and monitoring data to the control plane when feasible. Since communication with the control plane is asynchronous, the API gateway must be resilient to intermittent control plane availability or connectivity issues. The dual plane architecture of a modern API platform allows a single control plane to centrally configure and manage API gateways, the different one, deployed across multiple cloud services providers and on-premises environments in case that we are in hybrid IT infrastructure. So, let's see how we can build robust, secure, and scalable APIs. Because we know that's not easy to do. It's easy to create APIs, but how we can build them as scalable, how we can secure them, how can make them robust. Delivering APIs is a critical task for organizations using modern application and integrating architectures. They provide a foundation on which to create a successful, composable application architecture where partners, clients, and stakeholders interact through software. To ensure the APIs you deliver are valuable for the developers and integrators using them, you must ensure that these APIs are sustainable. In other words, you must ensure they remain useful, secure, and stable throughout their life and the life of the apps and processes that consume them. Providers of APIs deliver infrastructure interfaces that provide access to functionality and data in a way that should be easy for API consumers to use. API consumers are developers who use an API's functionality to create new business solutions. API consumers rely on the APIs they use being secure, performant, stable, and available for the lifetime of their applications. Poor API delivery has far-reaching consequences for both API providers and API consumers, including high delivery and maintenance costs, poor customer experience and loss of revenue, missed business opportunities through lower productivity and slower delivery, increased risk through poor security and identity management. This raises the question that this research aims to answer: how to deliver and support APIs so that developers can easily discover and use them to build valuable solutions. Let's answer to this question. We advocate for a customer-centric approach to harmonize service implementation, architecture, and API lifecycle, ensuring APIs are secure, available, and well supported. Why we'd like to focus more about this approach. So this approach contrasts with a bottom-up, provider-centric perspective by prioritizing the needs of API consumers rather than the viewpoint of the API provider. Focusing solely on the provider perspective often leads to the creation of APIs that serve as the simplest abstraction layer overlaid on an existing domain model without sufficient input from consumers, potentially compromising encapsulation and fostering coupling. Form part of a set of services model, resulting in direct access and tight coupling to the domain model, leading to undesirable dependencies, also known as domain model dumping. As sustainable API must fulfill the requirement of consuming developers. Specifically, it should provide necessary and relevant functionality. It should offer clear definitions in technical and non-technical contracts. Be thoroughly documented and easily comprehensive. And be well implemented to meet both business and consumer needs. Undergo testing for performance, reliability, and accuracy. Ensure ease of and consistency of implementation for consumers. Be discoverable with transparent versioning, bug fixes, and enhancements. Support monitoring and analytics to enhance quality and availability. And implement consistent security measures and access controls. So, let's go move to the last part of our session today that's related to security best practices. We have some best practices to present here. We can have more. It depends from your organization. It depends from the different security requirements inside your company. So let's start with the first one. Let's implement EIM and security. So your next step is to implement access control for your platforms and your administrative UI, user interface, followed by the security infrastructure that will protect both the platform and your APIs. Not only is every API a potential attack surface, for example, your API management itself is a target for attackers. Work closely with your security team to secure your platform as you link your platform to your authentication authorization system. If you are using any authentication system internally, you can link your platform to that. So, lock down all other access, which means you need to ensure the default administrative access accounts are removed and entirely or completely disabled in this case. Review the platform's default roles and edit them to perform to your security model. Remove any superfluous roles and ensure that all roles have the minimum permission necessary to accomplish their responsibilities. Ensure that your DDoS protection will shield your platform and use the best tools to protect your platform from this type of attacks. Ensure that both mitigation, firewall, for example, and ADCs are in place. If you use a CDN, ensure that you have correctly configured its cache policies to work with your APIs. You do not want to create security or privacy risks by caching sensitive contents in your CDN. Equally, you do not want to cache and serve stale data. For additional guidelines on API security, including the types of threats that APIs face and approaches for defending against them, you can see a documentation related to the production. For example, you can see documentation called protecting web application APIs, for example, from any attacks in this case. So I highly recommend to see how you can really protect your APIs from any exploitation from outside. To configure endpoint protection capabilities, in this case, one of the most critical capabilities of API gateways is their ability to provide protection for API endpoints. There are two types of endpoints protection capabilities. The first one is the rate limiting and throttling limit access to an API endpoint, while circuit breakers protect both the API endpoint and its consumer from failure. Implement API mediation, which means that your API gateway is a starting point for your API mediation. You will use it to enforce security and access control policies and to monitor and manage traffic to your APIs. You will also do some amount of transformation in your API gateway, such as converting XML data packets to JSON, for example, and use caution when implementing transformations in your gateway. As noted above, doing so both burdens the gateway and create lock-in to your current vendors. If you need more complex mediation, such as complex mediation of API payloads or orchestration of API calls across multiple inner API, you can leverage a separate integration system, because Mediator it's like in between source API and your API management. If your API management is deployed on premises and publishing APIs from on-premises system, you should prefer an ESB, DEIP, or custom mediator located on premises. But if your API management is in Azure, in cloud hosted, and publishing APIs from on-premises systems, you can either choose an on-premises solution in this case, or use an infrastructure platform as a service as mediator. iPaaS, we call that. If your API management is cloud-based and publishing APIs from cloud-hosted systems, you should prefer an infrastructure platform as a service as mediator, iPaaS in this case, iPlatform as a service. This is your mediator. And the last one is how to configure analytics and reporting as best practice for security. So analytics and report, it's recommended for any solution, because analytics and reports are critical tools for understanding how your platform and APIs publishes are performing. They also provide valuable evidence for stakeholders, that your platform and its APIs are meeting expectation, and can identify cases where it's not. The data produced by your platform is useful to many audiences, and you should ensure that all of them are getting what they need. For example, if you are monetizing APIs on a per call basis, then you will need to provide access to information on usage and costs to the developers who are consuming your APIs. This will allow them to understand and manage their costs. And to secure APIs in Azure API Management, you have two methods, let's say. It's by using subscription or by using certificates. Subscription key or plan, access control policies, we will talk about monitoring analytics, certificate management, certificates in Azure Key Vault, or we just configure API management policies to secure our APIs, to secure our platform. When you publish APIs through API management, it's easy and common to secure access to those APIs by using subscription keys. Here we will start with securing APIs using subscription. If you have multiple subscriptions here, we can manage that and secure them using these best practices. So to get the subscription key for accessing API, subscription is required. Subscription is essentially a named container for a pair of subscription keys. And subscription key is a unique auto-generated key that can be passed through in the headers of the client request or as a query string parameter. And here we can see how we can secure by subscription. We select our API management, we have APIs, under APIs we have subscription, and we can generate always our keys. So application that call protect the APIs may include the key in every request, and we can generate this key multiple times and at any time. And every subscription has two keys, primary and secondary. We find it here in APIs under subscription. Now, to secure APIs by using subscription, we have the keys that can be passed in the request header. We can see here, or a query string in the URL. So the default key named is OCP API Management subscription key, as you can see here. So you can use the developer portal to test out API calls. If you create internally on premises your API, self-hosted APIs, you will use the same key to be able to interact with your content that you already created. And let's go here to talk more about securing APIs by using certificates. Certificates can be used to provide transport layer security, TLS, mutual authentication between the client and the API gateway. So you can configure the API management gateway to allow only requests with certificates containing a specific thumbprint. The authorization at the gateway level is handled through inbound policies. And in the conception tier of Azure API Management, you can use certificate authorization policies to handle client certificates. These policies allows you to perform various checks on client certificates to ensure secure access to your APIs. So here is how you can shift specific tasks using certificate authorization policies. The first one, to check the thumbprint of a client certificate. So you can use policies to extract the thumbprint of the client certificate presented during the SSL or TLS handshake. And you validate this thumbprint against a predefined list of acceptable thumbprints to verify the authenticity of the client. Another policy, let's say, check the thumbprint against certificate uploaded to API management. So, first step, to configure API management to store and manage certificates, including client certificates and its key vaults. The next step is to use a policy to retrieve the thumbprint of the client certificate and compare it against the thumbprints of certificates stored in API management key vault. Another policy is to check the issuer and subject of a client certificate. So, first step is to extract the issuer and subject's information from the client certificate presented during the SSL or TLS handshake. Next, we validate this information against predefined criteria to ensure that the certificate is issued by a trusted authority and belongs to an authorized user and entity. By implementing certificate authorization policies in the conception tier of Azure API Management, you can enforce strict security measures to verify the authenticity and authorization of client certificates accessing your APIs. These policies provide a robust mechanism to protect your APIs against unauthorized access and potentially security threats. So to summarize, we talked in the beginning a bit about API requirements, the different challenges, why we need to use API management platform. After we talked more about the different features inside the API management platform, Azure API Management, API gateways, self-hosted API gateways, developer portal, Azure portal as administrative portal. We talk about data plane, control plane, the difference between them, how they interact with each others. We talked more about how to create APIs, to build APIs, robust, secure, scalable APIs, and in the end we talked more generic about how we can, the best practices in security, and how we can do that inside Azure platform management by subscription and using certificates, let's say here. Thank you for joining me today, and don't forget that you can join me after the session using these links, and by email. You can reach me by LinkedIn, Twitter, or you can see on my blog. So I'm writing a lot this period about APIs management, the best practices, how we can create the self-hosted, in which environments. Thank you and have a nice day.